preview video. Solve a system of equations using elimination, but a little bit harder than before. Remember what we've learned, that a system of equations is two or more equations with the same variables, and that their solution is the ordered pair that makes both equations true. On a graph, it's where the two lines cross. Also recall that we can take our two equations and we can look for an additive inverse, add them together in order to eliminate one of our variables, and that allows us to solve for a variable, substitute that in, and find the other variable. But what happens if an additive inverse does not already exist? For example, if we add these equations, we have x plus 5x, which gives us 6x. We have y plus 2y, which gives us 3y. And over here we'll get 30. Well, having the equation 6x plus 3y equals 30 doesn't get us any closer to solving our system. So we need to figure out how we can create an additive inverse. In other words, what can I multiply one of these equations by so that I get an additive inverse? Since I see that I have a 1x and a 5x, I know that one option would be to multiply the whole top equation by negative 5. If I do this, then I'll have negative 5x and 5x, which will cancel out. I also could look and create an additive inverse for the y. I have 2y, so I could multiply the top equation by negative 2 to give me negative 2y and 2y. The most important thing to remember is that we have to multiply every single term in an equation on both sides of the equal sign in order to not change the value of that equation. So I think it will be easier to multiply the whole top equation by negative 2. That means that I'm distributing it on both sides of my equal sign. My new system of equations becomes this: negative 2x minus 2y equals negative 14. I didn't have to change my bottom equation at all, but I'll copy it over anyway. 5x plus 2y equals 23. Now I can solve my system just like we learned yesterday. So I have 3x plus 0y equals 9, or 3x equals 9. Oops. That means that x equals 3. Now that I have my x equals 3, I can substitute it into any of my equations, either the new ones or the old ones, and I think the easiest one will be that top first equation, x plus y equals 7. Since I know that x is 3, that means that y is 4. So my solution is 3, 4. I should, of course, check this in both equations. 3 plus 4 equals 7, so I know my solution works in my first equation. 5 times 3, or 15, plus 2 times y, 2 times 4 is 8, equals 23. So I know it works in my second equation as well, and my solution is 3, 4. In other words, I used my elimination method, but since I didn't have an additive inverse, I multiplied one of my equations, and sometimes you'll have to do both, in order to make an additive inverse. I chose negative 2 because I had positive 2y, so I knew that multiplying every term in my first equation by negative 2 would get my y's to cancel out.